Myself, Dr. Sushma Jain, Associate Professor Chemistry, Government Dungar College, Bikaner. In the previous lectures, we have discussed about the aromatic electrophilic substitution in monosubstituted benzene, and we also discussed ortho and para take. Now today, I shall discuss about electrophilic aromatic substitution in disubstituted benzene. When two substituents present in the ring, then new electrophile may attack on this position or this position or this position or this position. But where it will attack and what will be the substituted product controlled by some rules. These rules are, the first one is the when both groups present in benzene ring are ortho-para directing and present at ortho position to each other, then more powerful group control the orientation. Here the directing power of groups are O minus is greater than NH2, NH2 greater than NR2, NR2 greater than OH, OH greater than OMe, OMe greater than NSCOMe, and this greater than methyl group greater than halogen. Now we can illustrate it by the example. Here methyl group and OH group both are ortho-para directing and present at ortho position to each other. Here the OH group is more powerful than the methyl group, therefore the orientation is controlled by OH group, and therefore the new electrophile attack at this position or this position. In the second example, OH and NH2 both are ortho-para directing group and present at the para position to each other. Here the new groups comes at the ortho position to NH2 group, and when here also Me group and Cl group both are ortho-para directing, the more powerful is the methyl group, therefore the new group attack at the ortho position of methyl group and the para position of the methyl group. Now the second rule is when both groups are meta directing, then less powerful group controls the orientation. The directing power is given by Me3N plus, more powerful than NO2, more powerful than Cn, Cn more powerful than SO3H, SO3H more powerful than CHO, then COMe and then COMe. For example, here NO2 and Cn. The Cn is less powerful than NO2. Therefore, this Cn is controls the orientation, and therefore the new electrophile enter at the meta position of this Cn group. The third rule is if two groups are ortho-para directing and meta position to each other, then third group enter at the according to electronic effect and according to steric hindrance, but this third group does not enter between the two groups. Here the reaction of this compound where the two groups are ortho-para directing and meta position to each other, therefore the 60% isomer of trisubstituted compound is where the electrophile attack at the ortho position of Cl group, 33% where the electrophile attack at ortho position of Br or para position to Cl, and 1% compound is obtained where the electrophile enters between these two groups. Due to steric hindrance, it is very difficult to attack the electrophile to this position, therefore 1% of the substituted product is obtained. Now the fourth one is when one group is ortho-para directing and other is meta directing and ortho position to each other, then ortho-para directing group controls the orientation For example, here OH is ortho-para-directing and NO2 is meta-directing. Therefore, the new coming electrophile enter at the ortho position of OH group or the para position of OH group. Fifth one, when one group is meta-directing and other is ortho-para-directing and meta to each other. Here NO2 group is meta-directing and Cl is ortho-para-directing. Therefore, the meta-directing group controls the orientation and the new coming group enter at the ortho position of this meta-directing group. This is called ortho attack. Therefore, here electrophile attack the ortho position of NO2 group, or we can say the para position of the ortho-para-directing group. This is known as ortho attack because the new group come at the ortho position of meta-directing group. These are the 5 rules according to disubstituted compounds converted into trisubstituted compound by the electrophilic attack. Now second topic is Ipso attack, a position which is already occupied by a substituent in an aromatic ring is called Ipso position. Ipso is Latin word, it means itself. The attack on this position is called Ipso attack, and the replacement of the substituent present already in the ring is called Ipso substitution. For example, proto-dealkylation of alkyl benzene. This is the reverse of the Friedel-Crafts reaction. Here tertiary butyl benzene on protonation takes place at the Ipso position. Here the tertiary butyl group is already present in the ring and hydrogen attack, proton attack at this position and forms the intermediate of this type, intermediate cation. This one removes the CCH3 whole thrice C plus and form the benzene. The tertiary butyl cation is unstable, therefore it removes one proton and gain more stability and form 2-methyl propene. The second example is the rearrangement of alkyl benzene. Here 1,2-dimethyl benzene on protonation. The electron displacement takes from this carbon to this carbon. Therefore, this carbon acquires positive charge and this carbon acquires negative charge. The electrophile attack at the negative position, and therefore this type of the second product intermediate cation is formed here. Then rearrangement is occurs. The CH3 moves with their bonding electrons to this carbon atom to this carbon atom. Therefore, this carbon atom becomes neutralized and the CH3 attached to this carbon atom. And due to movement of this CH3 with their bonding electrons, this carbon atom gets positively charged. This carbon atom gets positively charged. Here, this carbon gets positively charged, and in the next the proton removal is takes place from this hydrogen atom. This hydrogen removed as a proton and gives their bonding electron to this carbon atom. Therefore, this carbon atom becomes negatively charged. Here positive, here negative. Here bond formation is takes place. Therefore, 1,3-dimethyl benzene is formed. Here the rearrangement of 1,2-dimethyl benzene to 1,3-dimethyl benzene is occur. The one more example of Ipso attack is bromo desilylation. Here this compound on bromination gives para-bromo benzoic acid. This is the example of Ipso attack. The proto desilylation, here this compound on protonation gives this type of the intermediate. This protonation is takes place at the Ipso position, the position where the substituent is already present. Therefore, this type of the intermediate cation is formed which react with water and one proton is removed and the benzene is formed. Thank you.